As much as we would all like to close our eyes and pretend that errors don't exist, we still have to deal with exceptions on a daily basis. Modern languages, including Dart, support exception throwing and catching. However, if you've developed apps for some time, you may have become frustrated with this special flow of errors in the program. So, is there a way to return errors just like you return regular values while keeping the code maintainable? In this two-part series, you're going to learn how to deal with errors properly, and in the first part, which is this one, you're going to learn the best practices of classic error handling using try-catch blocks, because there are many things which can go wrong even with classic exceptions. And then in the second part, we will introduce powerful concepts from functional programming that will make handling errors even more streamlined. This is something you might have seen in my Clean Architecture for Flutter tutorial series, but over here in this two-part series we are going to expand on that even further. Hello, welcome to Reso Coder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming sought after developers. And also, if you want to meet up with the Flutter community, including me and people from Google, in January 2020, which is just around the corner in Warsaw, Poland, check out fluttereurope.dev, or also there is a link in the video description. There is no better way to learn error handling than on a semi-real app, and that's precisely what we are going to be building in this tutorial two-part series. Actually, you already have the app prepared for you as a starter project, which you can get from the link in the video description. But first, let me show you what this app entails. It's a very simple concept. You just press this button and it's going to load this post from a fake API, and this post simply has ID, user ID, title, and body, and it's gotten from the fake API as a JSON string, as you can see over here, and then we of course parse it into some sort of a model class. We convert it from map using JSON decode just as usual, and then we have a possibility to throw errors from the fake HTTP client by simply uncommenting these lines. So we can either throw a socket exception, an HTTP exception, or we can return an invalid JSON, which will of course trigger a format exception when we try to parse this invalid JSON. And of course we also have some sort of a UI which displays what you have just seen. So we are currently doing that inside a stateful widget with a future builder, which simply displays a circular progress indicator, and then it displays either the error message or a post or the press the button text. And toward the end of this first part, we are going to migrate to a more mature state management solution using Provider. I just want to show you how to handle errors when you don't use any sort of a state management like this, when you have just a future builder inside a stateful widget. And the concepts which we set out for proper error handling in the first half of this tutorial will very much translate also to Provider or MobX or Block or whatever else of a state management solution you want to use, with some very minor changes. So if you want to get this starter project and also learn from the written tutorial, check out the link from the video description, where you can find all of the code to this video, links to occasional libraries, and overall go through this lesson at your own pace. As we've already seen, errors can be thrown from the fake HTTP client. Currently we return a proper JSON, so we are good. However, when we short-circuit the execution of this method by simply throwing a socket exception, for example, so we uncomment this line, and now we're going to go to the app and get post. It just says press the button, but the error is not present anywhere, right? And we should definitely have an error displayed because we are checking if the future snapshot has error. We want to display the error string. But currently it seems that because we are just outputting press the button style text, it means that there is no error present in the snapshot. So why is that? Well, that's because currently we are handling errors in the worst possible way, and honestly, if you handle errors like this, it's just much better to let them propagate throughout the app and crash the app in the end, because what we are doing currently is that we just catch any kind of an error from the post service, which simply calls the HTTP clients method, which throws that exception. And whenever we catch any kind of an error, we just print it out to the console. So yes, we are catching an error. The app will not crash. As you can see, it prints out socket exception, no internet 3 times because we've pressed the button 3 times. But the problem is that printing out to the console will not make the user aware of the error. There is nothing present in the UI which talks about the error. So the user will probably think that we have just a buggy app which does not do anything, because the user will have no clue that some sort of an error occurred. But you might think, we are using a Future Builder, and as a good Flutter developer knows, Future Builder catches errors itself. After all, it has this field has error which you can check for, and then you can get the error from the Future Builder's snapshot itself. So actually, we do not need to catch exceptions from the post service, right? We can just let them propagate freely to the UI, and the UI will take care of them itself. So let's try that. Let's remove also this comment, and let's remove the catch, and let's save that, all right? So what we can do now, we are still throwing a socket exception. So let's just, again, press the button and we get a crash of the app, supposed crash. However, do not worry if you get something like this, because that's just probably a bug in VS Code, because actually this exception has been caught by the widgets library, more precisely by the Future Builder. So we can just nicely continue with the execution of this program, and so that we do not get any further supposed fake app crashes, we can go to the debug tab, and down here we want to uncheck uncaught exceptions. So once you have that unchecked, you are not going to get these fake positives, although you are not going to get any positives either. So just keep this in mind if this uncaught exceptions is unchecked. That's just a bug with VS Code. But either way, whether we have the bug or not, if we now open up the emulator, we can see that we have a socket exception message present right over here. And we can also change it to HTTP exception. So let's just try all of the exceptions. Nice. And also if we have an invalid JSON format, it's going to print out the format exception. But you know, the issue with this simpler approach is that we do not want to display these low-level error messages to the user. Because what is this talking about? Like, we have an invalid JSON gotten from the supposed server, which we are faking currently. So the user really does not even have to know about some characters which are returned from the server. We should really format this to say something like internal error or bad response or something like that, because this is just scary to the regular user and it doesn't tell him anything which is useful. And also another very much huge issue is that currently we basically again have some sort of a blanket catch statement. Even though we have not written it ourselves, we are still catching every kind of an exception which is thrown in the Future Builder, then outputting it as a text widget. The issue with catching every single possible exception which is thrown, and that's also sort of an issue of using a Future Builder, is that what if there is some sort of an unrecoverable error upon which it's just much better to crash the app? You know, you have these fatal errors all the time, at least on Windows or on some apps, like fatal error, the app crashes, you cannot continue. Something like that can happen. I don't know, maybe you are building a banking app, and when there is some problem with the transaction, it's probably just better to crash the app than to let the improper transaction go through and do some monetary harm to some people, right? So just to recap, what do we want to do? Well, we want to customize error messages and also make sure that we catch only these particular types of exceptions and nothing more, just to be safe. So what can we do about this? Well, we can of course reintroduce the try catch block. So let me just write try. We're going to grab this code and move it upwards, and then inside catch, we're going to write something. Well, sort of, kind of. We of course do not want to catch everything. Instead, what we want to do is that we want to utilize Dart's weird syntax, because in other languages you may be used to something like catch, socket exception, E, and so on. But over here in Dart it's a bit different. So instead of doing catch, socket exception, E, if you want to catch only a socket exception, you are instead going to say on socket exception, and then you can either catch E or you don't have to. So we actually do not want to get the error. So we can just leave off this catch part. And with that, we're now catching only a socket exception. And we want to do the same thing for all of the other exceptions which can be thrown from the fake HTTP client. So we also want to catch a HTTP exception and also a format exception. Okay. So now we are catching them, but we are not doing anything with these three particular exceptions. So we want to do something, but we mustn't let ourselves slip into just printing out some messages, because then we are going to arrive in the same situation as we were at the beginning of this tutorial. Although it's a better situation because we still let other non-code exceptions propagate, but still, we are going to be only printing. So something like no internet connection, and also a neutral phase. All right, or maybe this one. And we can do that for all of the other exceptions as well. So for HTTP exception, we're going to print couldn't find the post, and for format exception, we would print something like bad response format. But this is no cool, because still when we now run the app, you know what's going to happen. Of course, nothing will be propagated to the UI, so we want to get post. And again, the error message will be just printed to the console, bad response format, right? But we won't get that error message displayed to the user in the UI. So of course, what we can do is rethrow an exception. We could do that. We could just rethrow, for example, the socket exception. And with rethrow, if we now output the socket exception and run the app again, so we press the button, we have just gotten rid of the awesome message saying no internet connection, and instead we are again printing some socket exception, which does not tell a lot to the user, although the latter part of the message tells him something, but still we want to print this nice message with an emoji. So the solution to throwing an exception only on particular exceptions when they are called, and also customizing the error message, is to not rethrow, of course, but instead we want to create our own custom exception type, which will be used solely for the purpose of getting the exceptions from outer boundary layers, for example, as this post service, because post service communicates with an HTTP client, so it's an outer layer of our app. And that exception will be responsible for just getting these messages to other layers of our app. So the trick is to create a single app-wide failure class, and let's just create it right below the post service. It will be a class failure, and it will have final string message, and we want to have this message in the constructor populated, and then we also want to override to string, where we will just return an arrow function, so expression bodied method message. Because we are in Dart, this class failure does not need to extend exception, because in Dart you can throw any sort of an object. It doesn't need to be an exception. And we are going to utilize that feature of Dart to our advantage. And also, if you want to translate these error messages, you probably do not just want to pass around strings like that. Instead, you would probably have something like final int code, and you would pass around just these integer codes and then translate to a proper message, to a proper language in the UI layer. But we are building only an example app, so we are good to go with messages directly. And now what we want to do is simply, instead of printing, we're going to throw a failure, and that's it. So we want to replace every print with throw failure. And now what's going to happen is that if we now hit the button, no socket exception will throw no internet connection failure. So we have a nice message. And also we can try it out with all the other exceptions. So HTTP exception will get us couldn't find the post, and the last one will show us bad response format. And of course, just to test out if even the proper path, the happy path of the code works, we're going to test it. If no errors occur, we should get the post displayed nicely, and we do, which is a good thing. This is how you can handle errors using a stateful widget, which is very simple state management solution, but it still works for simple apps. However, if you have something more elaborate, a bigger project, you probably do not want to use a stateful widget for your state management. And that way you also probably aren't going to use a future builder, which sort of handles exception catching itself, and printing out errors from a future builder is very simple. You do not need to do any additional setup. So because of that, I also want to show you how to handle exceptions properly when you use a more elaborate state management solution. And the simplest one to show here is provider. However, these techniques will work more or less with minor modifications also for MobX, block, Redux, whatever else you want to use. We're going to use a simple change notifier with a provider. And also, if you want to learn how to handle errors properly solely in block and also learn clean architecture along the way, check out my tutorial course from the card in the corner, which is going to teach you just that, all using the block library. Actually, there are not a lot of changes we have to make to our code, at least not to this one, which handles errors and throws failures, in order for it to work with change notifier. So let's just first create a brand new file, post change notifier. And also, because this is definitely not a tutorial about change notifier, I do not want to bore you to death by watching me type out a long as notifier. So I will just paste the code which is present in the written tutorial. So go over there and get it yourself if you want to follow along. All right, so here we go. And what we have inside the change notifier is a notifier state, which of course can be initial, loading, and loaded. Initial state will of course display if we restart the app, it will display this message, press the button, this is the initial state. Then we have loading state, which will display this circular progress indicator. And then we are gonna have also a loaded state, which will display either this nice post or an error message. Of course, we depend on post service because we wanna get the data from somewhere. And inside that post service, remember that we are still handling all of the exceptions and changing them up to be failures with proper error messages. So that's still taking place in the post service. And basically we then just have 3 glorified fields in the change notifier. Glorified because we have one private field, then we have one public get only property, and then private setter. We could also go with a property setter, but I feel that setter methods are more manageable. I just like them better. But you can use getter and setters properties just as well. So whenever we set a property, we notify listeners so that we can update the UI. And that's basically it. There is nothing more to that. We have a state field, post field, and failure field. So we also want to store the failure, at least with this first approach, because in the second part, which is coming up next, you are going to learn how to handle errors even better using some concepts from functional programming, which are pretty powerful. But for now, we still store the failure as a separate field. So there are some specificities which stem out from this decision, but we are going to run with that for now. As I said, in the second part, we are going to change this. And then we also have just one method, which is void and public get one post. And over here, as soon as it's called, we set the state to loading so that we display this nice loading indicator. And then we have a try catch block, and we catch only failures. So whenever a failure happens, we are going to actually also catch the instance of the failure, and we are going to call set failure. Otherwise, we are going to call set post with the post which is gotten from the post service. And then we again set state to be loaded so that we can update the UI. And some of you might get heart attacks if you see this code, because you are going to say, Matt, this is so unoptimized, what you are doing. Like, you are calling notify listeners from set state and also from set post, set failure. You're going to have unnecessary builds, rebuilds of the UI. Well, just chill out. This is just a simple project. But yes, you could optimize it by even removing the notify listeners from set post and set failure, because after all, you are always calling set state, which notifies listeners as well. But let's just leave it as that. I'm not going to change this code just for you purists out there. And again, notice that we are catching only failures in the post change notifier, or you would also do the same thing in a block or in a mobx store or in a reducer, wherever else. And we still leave out the actual error management and converting the feature-specific errors to app-wide failures to the post service. This does not change even when you introduce some sort of a middle layer in a way of a proper state management solution. You still want to handle the particular types of exceptions and convert them to failures as soon as possible in the outer layers of the app, because I hope you agree that post service is an outer layer because it communicates with a HTTP client. However, our post change notifier is a more inner layer because it does not really depend on some classes which we do not own. Granted, we do own our HTTP client, but that's only because it's fake. If you are using a proper HTTP client, a live one, you are not going to be able to change its code as easily. So really, catch particular types of exceptions as soon as you can and then convert them to app-wide failures. That's because you want to follow the single responsibility principle, and since our post service has the responsibility to communicate with HTTP client, I think that main responsibility entails also the responsibility to handle errors coming from the HTTP client and also, of course, from JSON conversion of a post. Even if you do not want to follow single responsibility, this approach of handling exceptions close to their source will still be beneficial to you because you have much less chance of forgetting to handle a particular type of exception when you handle it close to its source. Because if you have multiple services in a change notifier, it's very, very easy to forget about some type of an exception which you would want to catch. Alright, so moving on, we have the notifier set up. So now what's left for us to do is to modify the UI. So currently we have a future builder and a stateful widget, which depends on a post service itself, and also it stores the future of the post. We can remove all of these dependencies because we have them over in the post change notifier. And also let me just show you that the starter project already comes with the provider dependency. So if you want to follow along, just be sure to use the same provider version, which is currently 3.2.0. In a short while, 4.0.0 version will come out, but it will change a few things. So just make sure that you are using 3.2.0 just to follow along. Of course, before using provider, we have to provide the change notifier down to our home widget. So we're going to just wrap it with a new widget, which will be a change notifier provider. Notifier provider, its child is home, of course, and also we want to have a create method, which will simply instantiate our post change notifier. Currently, we are still using the future builder in our widget. We're gonna leave this in here just for now, and above it we're going to create a consumer. consumer of post change notifier, and it needs to have a builder, of course. Let me just put a comma at the end, and inside this builder we want to have a function granting us only the notifier. We are not interested in the build context nor the child. So 2 underscores, and inside this method we're going to do basically the same thing as we are doing in the future builder. It's only going to be working with the change notifier. And again, because this is not a tutorial about change notifier, I am just going to paste the code over from the written tutorial. So what do we have here? Well, it's basically the same thing as we have in the future builder, because if the state is initial, we return style text press the button. If we are loading, we output circular progress indicator. And if we are neither loading or we are not initial, that means the state is loaded. And here we have to check if the failure is not null. In which case, if it's not null, we have an error, so we want to print out the failure converted to string. Otherwise, there is no error, so we can print out the post, which we have gotten from the fake HTTP API. And with that, we can now remove the future builder. And also in the raised button, we are no longer just going to set the state and call post service directly. Instead, we are going to grab a provider. And with that, we want to get an instance of our change notifier, so post change notifier. And on it, we want to call get1post. And with this, if we now check out the app as it's running, it's still going to work. And just to test it out once more, we are going to, for example, uncomment this HTTP exception, and we should get a nice error message printed out, and we surely do. So the code we have written in this first part is good enough. However, we can make it a lot better by introducing a few practices from functional programming. But first, if you want to go through this tutorial at your own pace once again, because there may be a lot to process, and also if you want to get all of the code, check out the written tutorial available from the link in the video description. With that said, we have some issues currently which are present in the code. For example, we currently have only one failure here, but what if our change notifier will do more than just get a single post? What if we have some other data field over here as well? Will we also have to have multiple failure fields, or we are just going to throw everything into one failure field, no matter where that failure is coming from? And also, what about this if statement in main.dart, where we are checking if failure is not null? Currently, we are relying on good practices and conventions so that we have to remember to check if failure is not null. But wouldn't it be better to be forced to handle failures? No matter if we remember to handle them or not, we are going to be forced to do that through the support of the Dart compiler. Whenever you can rely on a compiler, you should rely on that and not on your own memory, because your memory is unreliable, but the compiler is reliable because compiler has rules, and if you do not follow them, you can be sure that the compiler will give you a hard time about it. And all of these problems stem from one thing, which is that the flow of errors is currently different from the flow of the success data, because we are just throwing exceptions all over the place and then we have to catch them. And even though we have streamlined the process with a failure, which is app-wide and used for getting the exceptions across to the change notifier, still the flow of exceptions is throw and catch, and the flow of regular data is just nice return values from a function. So in the next part, you are going to learn how to also return errors together bundled with the data, and we are going to use functional programming concepts such as either, task. We're going to map over the function to cast the either type to hold only failures, and overall you're going to learn a lot in regards to functional programming and also in regards to proper error handling. And if you have watched my tutorial, and if you have watched my clean architecture test-driven development tutorial series, this error handling will be even better than what we have over there. So definitely stay tuned for that, no matter if you've seen that series or not. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at the job, go to flutter.education, and link is also in the description, to get the top curated Flutter news and resources aimed at improving your app development career. Over there, you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. So if you do not want to miss that next part and also more tutorials like this, be sure to subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become a sought after Flutter developer. And if this video helped you with understanding how to handle errors properly and how to get them over to a change notifier or a block or a Mobx store, give this video a like and also share it with other developers who will surely benefit from this too. Leave a comment if you have anything to say, and see you in the next video.